All right, out of special requests by Davinci, we're gonna do Algebra 2. So that's great. So off chapter 1 test. So which of the variables is the dependent variable? So pretty much independent, dependent. Well, what depends on the other? So the number of ball bearings is independent. You choose how many ball bearings you put in, how much it weighs. The ounces is dependent. So what is the dependent variable? It's the ounces. Now, fill in the table. What is the weight of each individual ball bearing? So to do this, we have to set up two equations pretty much, and it's this one and this one. So we can do three ball bearings times what each individual ball bearing is, which is unknown. So we can do x plus the weight of the jar, plus we can just do y is equal to, and it's given 8.1. Then we have another one, so same setup, 7x plus the jar weight equals 14.9. Then from there, we can just subtract these two. So minus 3x plus y equals 8.1. And by subtracting these, the y's cancel out, and this goes to 4x equals, and then 14.9 minus 8.1, we get 6.8. Now, how do we solve? I hope you should know how to do this. Divide by 4, divide by 4. So 6.8 divided by 4 equals 1.7. So each ball bearing weighs 1.7 ounces. So we can just highlight that. And then from there, we have to plug in this number back into either one of these equations to find out how much the jar weighs. So we can do 3 times 1.7 plus our jar weight equals 8.1. Now we can just easily solve for y here. 3 times 1.7, right? And then 8.1 minus that to get 3. So y equals 3. So now we can fill in the rest of the chart. So when there's one ball bearing, it's 1 times 1.7 equals that plus 3, because the jar was 3. So this is 4.7, then 2 times 1.7 plus 3, 6.4. 4 times 1.7 plus 3, 9.8, and etc. I'll just continue. 5 times 1.7 plus 3, 11.5. Sorry, 6 times 1.7 plus 3, 13.2. So now that's filling out all of them. So now we have to figure out what is the weight of the empty jar when there's 0 ball bearings. So when there's 0, it's 0 times 1.7 plus 3. And what does that equal? Well, 0 times anything you should know is 0. So 0 plus 3 is just 3. So this is 3 ounces. Now find a function relating the total weight of the jar to the number of ball bearings. So pretty much we kind of already set this up with this one over here. So we can do the total weight being W, the weight of number of ball bearings can be X, equals pretty much, it equals the number of ball bearings times 1.7 plus our jar, which is 3 ounces. So this is pretty much our function, or we could rewrite it as Wx equals 1.7x plus 3. Either way is fine. I think Mr. Lindsay might prefer this way though. Now, how heavy would a jar of 15 ball bearings be? Well, what do? Plug in 15 for the x. So 15 times 1.7 plus 3 equals 15 times 1.7 plus 3, 28.5. 28.5 ounces. Boom, and that's how you do the first 5. Now for these two at the bottom, sketch a relation between x and y such that y fails to be a function of x when x equals 3. So here's our little graph here, and this is where x equals 3. And pretty much it has to fail the vertical line test, so y has to be 2 times at the x. So this is really easy. One way you could do it is just boom, or you could make it to where it crosses 3 twice. So boom and boom. That fails, so that fails. And either of those are fine. And then, is this relation a function? Justify your answer. So we have to figure out if each individual x value goes to a singular y value. And if it goes to multiple, then that's not a function. So 0 goes to 4, okay, that's okay. 1 goes to 2, it's fine. 2 goes to 4, fine. 3 goes to 4, that's, all of this is fine. So yes, this is a function. Sorry for the bad handwriting. So yeah, that's how you do those, because each individual x doesn't go to more than one y. For 8 and 9, unfortunately, I cannot answer these because it's Davinci's fault. He didn't send me the actual graph, so I can't judge anything. What is the domain of the function? Well, the domain is all the x values, and that's pretty much it. And what is the range? Well, it's all the y values, and that's how to do domain and range. I don't know. There's no graph, so I can't do that. All right, for the next ones, evaluate and simplify. This should be pretty easy. Negative 3 squared, well, it's the negative is inside the parentheses, so negative 3 squared is just pretty much the same as 3 squared, which is, you should know, 9. 1 minus 9 equals negative 8. That's how to do that one. 11, now negative 2, blah, blah, blah. PEMDAS, what's in the parentheses first, so 2 times 4, what is that? 8. So 5 minus 8 times negative 2. What is 5 minus 8? Negative 3. Then negative 2 times negative 3. What is that? That equals positive 6. That's how to do that one. 12. Now absolute value 6 minus 2x if x equals 5. Well, how do we do that? Plug in 5 for x. So 6 minus 2 times 5 in absolute value. What is 2 times 5? That's 10. 6 minus 10 in absolute value. What does absolute value do? Pretty much just makes it positive. So 6 minus 10 in reality is negative 4, but negative 4 absolute value just comes to positive 4. Then 3x squared minus y squared if x is negative 1 and y is negative 5. Well, literally just plug in the numbers. How hard can it be? 3 times negative 1 squared minus negative 5 squared. Literally just use your calculator. 3 times negative 1 squared minus negative 5 squared, and we get negative 22. Please just use your calculator. That's how you do those. Okay, for this one, solve without graphing. So 8 minus 2x is greater than 10. Well, just minus, so negative 2x minus the 8, so 10 minus 8. Negative 2x is greater than 2. Now you have to divide negative 2 by both sides. And when you divide by a negative, you have to flip the sign, so it becomes x is less than negative 1. So that's our answer to number 14. 15, when it's absolute value, it's x minus 10 equals plus or minus 3. Then we can just solve from there. So x equals, you add 10 to 3, 13, or you, so 10, negative 3 plus 10, which is negative 7. Now, 16, 2x minus 6 is greater than 10. And then we just pretty much 2x is greater than, you add 6, so 16. And then divide by 2, x is greater than 8. And then 17, x plus 3 is less than 2 minus 3, so absolute value of x is minus 3. Minus 3 is negative 1. Now, is this possible? Is the absolute value of x, can it be less than negative 1? Well, no, because absolute value gives all positive values. So this is undefined. It is not real.